Welcome to class. Today we will talk about fruiting substrate and growing morel. Mushroom substrate is equivalent to mushroom food and habitat. So what is a mushroom substrate? To successfully grow mushroom, you need to make sure that you're using the correct substrate. Using substrate to grow mushroom is equivalent of using soil to grow plants. Fruiting substrate refers to the medium that your mushroom will grow in. The substrate provides mushroom with the nutrient, moisture, and energy they need to grow and fruit. By the end of this lecture, you will know what a mushroom substrate is and what is it used for. You will know some common mushroom substrate recipes and to prefer substrate of different mushroom. We'll also teach you how to pasteurize or sterilize your substrate and a lot more. Most cultivated mushroom are saprophytics, cellulose utilizing primary decomposer. So they are the first organism to colonize the cellulose and other compounds in wood, leaves, straw, seed, and more. A good substrate is dense in woody, fibrous material like lignin, cellulose, and hemicellulose. These contain a lot of carbon, which is main food source for your mycelium. Usually this will be some sort of natural waste product such as straw, wood chips, sawdust, or even paper. There are a variety of different substrate that growers use. Different species of mushroom have their own preference. So it's important to match your mushroom with the correct substrate to have the best chance of success. Example, this is shiitake grown on log, oyster mushroom grown on straw, and button mushroom grown on compost. So a good substrate needs to have 1 to 2% of nitrogen. Most substrate like sawdust or straw need to have additional material added to them to reach this threshold. Your substrate need to contain a small amount of trace elements such as magnesium, potassium, calcium, sulfur, and phosphorus. Most raw substrate already contain these minerals, but this does vary depending on where the material comes from. You likely need to experiment here to see if you need to supplement with additional minerals. Your substrate needs to be slightly acidic with a pH level of about 5 to 7.5. Some mushroom like oyster can tolerate a pH up to about 8. Your substrate needs to have a good structure to enable air exchange. This is necessary for mycelium to colonize well. Your substrate also needs a moisture content of 50 to 70%. Finally, your substrate needs to have an absence of competing organism. This provides a blank canvas for your mushroom to thrive. This is the common one with sawdust, sawdust, soil, and grains. If you don't want to worry about preparing your substrate, you can always buy ready to inoculate mushroom substrate bags. These come sterilized and all you need to do is add your own spawn or inoculum. You can also buy ready to fruit mushroom substrate blocks that are completely colonized and ready to fruits. When a bag of sawdust or other substrate is fully colonized, is called block. You will see this term frequently used when working with various bags of substrate. So there are a wide range of material that you can use as substrate to grow mushroom. Agricultural waste are a good source for the cultivation of mushroom. Some substrate are fairly conventional and common, while other are newer and experimental. You can see non-compost substrates. You can use anything in agricultural waste that is cellulose based, and you can grow a variety of mushroom, right? From oyster to enoki to shinoki to ganoderma, and then you have composted substrate that's usually used to grow button mushroom and straw patty mushroom. The first one we're going to talk about is straw. So straw is another cheap and effective material to use as a substrate. It can be purchased at a farm store or most places where you can find animal feed or bedding. So what's the difference between straw and hay? Well, straw is the byproduct of grain crops. So straw is the dead stalk of a plant after the valuable grains of the plants have been harvested. Hay, on the other hand, is a crop that is grown and harvested as a feed for cattle, horse, and other animals. It contains the whole plant, sometimes with grains and seed. You may also experiment with similar agricultural waste like cornstalk, sorghum. Straw is one of the most common substrate used for oyster production. Other agricultural waste such as cornstalk can also be used, and then you can also use invasive plants such as water. You can use a bunch of invasive plants as well as substrate. Here you see oyster mushroom going on a number of different type of straw. So different type of straw. There are many type of straw to choose from. Wheat and oats are the most common, most recommended. Rice straw is also a good option. Nutrient-dense straw such as pea straw are less recommended. You should also avoid hay. Straw is nitrogen poor, so it's semi-selective, so only certain organisms like mushroom-forming fungi can grow. Hay has excess nutrient that can promote the growth of other fungi. So if you're using hay or pea straw, make sure that those substrates are sterilized and not just pasteurized. See, barley, canola straw, oat straw, wheat straw, regardless what straw you use, they all produce beautiful mushroom. So there are some pros and cons with using straw as a substrate. Some of the pros are it's great to grow oyster and other mushroom on. The straw is cheap and effective, so a 30-pound bale of straw can cost anywhere from $5 to $10, and it's available at most feed store. Straw is light and can be it can be aerate. It can aerate the substrate. It's not very nutritious, so that reduces contamination. Some cons associated with using straws are it's poor in nutrient and it's not dense, so the yield is not as great as substrate like sawdust. This is why straw is typically a one flush wonder. The second flush can be kind of poor or can be contaminated. It's also a bulkier to store. Think how aerated it is. And it's messy to work with and can be contaminated with animal manure if it's used as bedding, or it can be contaminated with dirts. That's pretty common. It's also need to be chopped up to be 3 to 4 inches for commercialization. There are several methods that you can use to prepare straw, such as heat pasteurization, lime bath treatment, peroxide treatment, and cold fermentation. This is lime treatment, and this is cold fermentation. See the foaming of it. So, preparation of straw substrate by heat pasteurization. First, the straw is cut to 3 to 5 inches in length. A shredder or weed whacker can be used. You just got to be creative. The second step is pasteurization. So, for indoor, a straw is placed in a pillowcase, nylon mesh, or any bags that has drainage. This is submerged in hot water at 180 Fahrenheit for about 1.5 hours. So you turn it on, wait till the water reaches to 180 Fahrenheit, turn it off, and keep the lid on, let it cool down. For outdoor, use a 55-gallon drum, wire mesh basket, and a butane burner. So you heat up the water with the straw in it to 180 Fahrenheit, turn off the Bunsen burner, cover the 55-gallon bucket, and wait for about 2 hours. Once the straw cooled down, drain the straw well. So a handful of straw, you should be able to squeeze it and produce no more than a few drops of water. You don't want it to be saturated with water. Next, you inoculate it with grains on a clean, smooth surface. Wipe down with 70% ethanol, rubbing ethanol. The next is preparation of straw by lime bath treatment. So first, again, you cut the straw 3 to 5 inches in length. You fill a clean 45-gallon drum or 55-gallon drum with fresh water. Add 4 cups of calcium hydroxide. Let's hydrate lime or calcium oxide, which is quick lime, while stirring it. Make sure you place the straw in a pillowcase or nylon mesh or laundry bag or similar, so you can easily remove it. Not necessary, but if you want to. Completely immerse the lime water solution for about 2 to 4 hours. Then after this, you drain and immediately inoculate the spawn. So one batch of lime water will treat about 40 to 50 pounds of straw. Next is preparation of straw substrate by peroxide treatment. Again, cut the straw to 3.5 inch in length. Place the straw in pillowcase, nylon mesh, and laundry bag or similar. And then you soak the straw until it's thoroughly wet for 2 to 4 hours. You drain and you rinse with water again. Then you drain. Next, you soak the straw in peroxide solution. So 1 liter, which is 1 liter of 3% peroxide to 1 gallon, or a final concentration of 0.6%. Keep the straw submerged in peroxide for 24 hours, after which drain, rinse with fresh, clean water. So after the second rinse and drain, immediately inoculate straw with spawn. So the next one is cold fermentation. So basically, same process. You cut the straw to 3 to 5 inches in length. You place the straw in pillowcase, nylon mesh, or something so you can remove the straw easily. You submerge the bag of straw under water for 7 to 10 days. This allows the fermentation by anaerobic organism and eliminate other microorganisms. For a whole bale of straw, keep submerged for 2 weeks. After this, drain well. The water is quite stinky, so avoid contact with your bare hand or clothes. Then you spread the straw on a clean surface and inoculate with spawn. So exposure to the wet straw to the air destroy the anaerobic organism, resulting in a straw that's pasteurized and ready for inoculation. So next, we're gonna move on to sawdust. Sawdust is very common use in mushroom production. You can grow a lot of medicinal mushroom, also good edible mushroom on sawdust. So hardwood sawdust is a common substrate for mushroom cultivation, as it's readily available and relatively cheap. Hardwoods such as oak, beech, and maple makes up for great substrate for many types of mushroom, but not all sawdust can be used to grow mushroom. Softwood can be used, but it's best to use sawdust from hardwood. In this course, we will consider any mushroom other than button mushroom a specialty mushroom, while you can grow oyster mushroom and 1 or 2 other mushroom on straw. Most specialty mushroom will be grown on sawdust. Sawdust is an incredible substrate. It's useful for many types of mushroom. Wood shaving are not as good as sawdust. Some grower age this material until it's more broken down. Wood chips are not the best material either. They are too large. Grower may age this until they become more decomposed. Wood pellets are sawdust compressed into pellet. These are available for wood burning stoves and standardized. They are not very expensive, but usually more than a direct source of sawdust. Look for pellet with no glue or chemical. So here you have sawdust. Is very fine. You want to work with this. Shaving is also okay to use if it's this small. And then wood chips and pellets. Sorry, this should have said pellets. There's some pros and cons with using sawdust. Some pros are you can grow almost any mushroom on this. It produces good yield via supplementation. It requires very little processing. Some cons associated with sawdust are it may be hard to get pierced hardwood. Mixed result with different type of hardwood. Substrate can be contaminated with oil from a saw machinery. Things to consider with wood substrate. So always use hardwood like oak, beech, maple, sycamore, alder, apple, almond, and other orchard trees. Coniferous trees like pine, spruce, cypress, and fir do not perform well. Cedar and redwood are resistant colonization by most fungi, including cultivated mushroom. Pine wood is colonized by only a few of the fungi commonly cultivated due to the terpenes and resin in the wood, and it's not recommended. Pine sawdust will work if it has been well weathered. So it has been outside for years in the rain, and over time, pretty much most of the terpenes and terpene and compound in the pine have leached out. So other things to consider with wood substrate are, for best result, you want to use sawdust or decomposed aged woody material. The coarseness of the wood of sawdust should be about that of from a chainsaw. Large chip may work for oyster and other vigorous mushroom. So sawdust are nitrogen poor and semi-selective, so only a certain organism like mushroom forming fungi can grow on it. Usually the substrate are supplemented with nitrogen to increase mushroom yield. When nitrogen is added, however, selectivity is somewhat lost. Other fungi will now grow in the substrate. So when you add a supplement, you have to sterilize it. So if high level of nitrogen are used, temperature of the substrate can also increase due to respiration of the fungus and other organisms. So there's a lot of food in the substrate bags. That's, if you supplement with nitrogen. So when the fungi grow too rapidly, it produces a lot of heat, and plastic traps heat. This can be a problem. So most of the time, you generally add bran, or you add the whole of the plants of the grains. So this rise in temperature due to biological growth is called thermogenesis. So some mold if present may lose dormancy at a temperature approaching 100 Fahrenheit. So more supplement increase the risk of higher temperature, which increase the risk of mold, which can cause problem. This is one reason you don't want your bag to touch. When they touch, they produce heat, and the heat is trapped between two of the bags, and hot spot can develop where they do. At moderate temperature, the mushroom consume or at least outcompete unwanted organism. Temperature of 75 to 85 are fairly ideal. Adding nitrogen to substrate always increase the risk of contamination, but you will certainly supplement sawdust with additional nutrient, or your yield will be relatively low. So whole log can be used to grow mushroom, especially shiitake, but the growth is generally slower and more unpredictable. Yield will be consistently faster and greater on sawdust in bag than on log. Supplement sawdust usually with bran, whole, or other grain to increase yield. Supplement substrate will need to be sterilized. You do not need to sterilize log. So the following are several species for growing specialty mushroom on sawdust. I routinely use the first one, which I call the Oregon recipe, only because it's similar to a recipe used by a couple of growers in the state. So the name has no real meaning. I made it up. The brand is either wheat bran or rice bran, which are relatively available to me. So you can switch that out with whatever brand that's relatively available to you. The millet and bran supplement the sawdust with nitrogen, oil, vitamins, minerals, and so on. Note the recipes are given in dry weights. So this composition is 76% oak sawdust, 12% millets, 12% bran, 65% moisture. To do this, you weigh out basically 1.5 pound of sawdust, 0.23 pound of millets, 0.22 pound of bran, 1.36 liter of water. This is a standard recipe. With experience, you may want to reduce the amount of water to 55%. The way you sterilize the bag of supplement sawdust influences how much water is lost during the process of sterilization. So just be careful with that. As with the previous recipe, notice that you want to use about 70 to 75% dry weight of sawdust. So you want the bulk of the material to be sawdust, and then bran, and then calcium sulfate. So here is the Pennsylvania recipes. As you can see, 50% of the weight or nutrient basically. So this is heavily reliant on nitrogen from millet, bran, and rye. So this recipe is kind of expensive. You want to keep it 70% moisture as well. So note that recipes are given in dry weight. This means that you will determine the moisture content of each ingredient. To do this, you place a sample of your ingredient, let's say sawdust, in a dish. Weight the dish empty, and let's get the weight of the sample in the dish. And then you place the sample and the dish in an oven at 220 Fahrenheit for several hours or overnight. So the target is a stable weight after heating it in the oven. So the time depends on how wet your sample is. If it's, your sample is super moist, you want it longer in the oven. Your text recommend 300 to 350 Fahrenheit for 1 to 2 hours. Again, this varies. Once it is completely dry, you want to weight the sample in the dish again to get the second weight, called the oven dry weight. So the difference between the first and the second weight is the amount of water lost. That figure divided by the original weight of the sample times by 100 is the percentage of moisture in the ingredient prior to heating. Next, we're going to move on to log as substrate. So mushroom cultivation on log started in Asia about 2,000 years ago. Note that not all wood can be used to grow mushroom. Softwood can be used, but it's best to use sawdust. It's best to use log from hardwood. Hardwood is a common substrate for mushroom cultivation as it's relatively available and relatively cheap. Hardwoods such as oak, beech, and maple makes for great substrate for many types of mushroom. Some pros and some cons associated with using logs are cheap, so you don't need to heat, steam, or you don't need a ventilation system to inoculate the logs. It's easy to access. It's long lasting, so once you inoculate and after waiting for a period, usually 6 to 18 months, the same log will continue to fruit for 3, 4, or even 5 years after. There's also a higher market price on mushroom from log than from other substrate. Some of the cons include it takes about 1 to 2 years after the logs are inoculated before they start producing their first harvest. The yield is unpredictable. Labor is pretty labor intensive. Logs are heavy, right? So, and they also need a lot of space. So there's no single way to grow mushroom, no single right way to grow mushroom on log. Here are some guidelines, basically. The first is choose a hardwood. Choosing the right hardwood, right? So there's a number of wood out there that you can choose. Remember, choose the right hardwood is always crucial. Diversity of hardwood. In your class handout and also here, I got this from North Spore's website. Basically, it lists the number of trees, the difficulty of how to grow that on logs, and also the stars or the best trees for that mushroom. For example, aspen is really good for oyster, and Italian oyster, chestnut, nemaco. You can see shiitake loves basically maples. It loves oaks. So basically, follow this guide if you have any question on trees. Just remember that alder and oaks are commonly used. Probably because alder is an abundant weed tree in the Pacific Northwest, and oak is common in the east. Birch, sweet gum, cottonwood, willow, elms, and other deciduous fruit trees may also be used. Remember, cedar and redwood are resistant to colonization by most fungi, including cultivated mushroom. Pine wood is colonized by only a few of the fungi commonly cultivated due to the terpene and resin found in wood, and it's generally not recommended. So when should you cut the wood? So the timing log harvest with sap flow can help increase the yield and longevity of your mushroom logs. This typically coincides with dormancy cycle. Two ideal times for harvest are during the fall, after 1/3 of the leaves have changed color or dropped, and also in the late winter to early spring before buds swell and leafed out. These are both times where sugary saps in the tree will become concentrated in the wood, providing nutrient for mycelial growth, and the bark should be tight, reducing the risk of slippage. For fall inoculation in grow zone 7 and higher, recommend protecting logs from freezing temperature and drying wind. Log can overwinter in heated space tucked away close to the wall of a heated structure, or store close to the ground and cover with leaves and blankets or tarps. So you don't want to harvest it when the buds are breaking or when the plants are growing in the summer. So what log size should you use? So any log size works. You can use branch or sapling if that's what you have available. Just keep in mind that small diameter woods will colonize faster, but will not produce for many years as larger log. You don't want the log to be so large or heavy that they are difficult to use. For drilling method, a 4 to 6 diameter with a 3 to 4 inches length is ideal. 3 to 4 feet length is ideal. For the totem pole method, you can use up to a foot or more in diameter and 6 to 18 inches high. So the wonderful things about mushroom log is that you will get multiple years worth of mushroom without having to re-inoculate your log. On average, a mushroom log will produce for 1 year per inch of diameter of the log. So if you inoculate a 5-inch diameter oak log with shiitake spawn, it will most likely produce for about 5 years. So what spawn should you use? So there's two types of spawn. One are called wood plug spawn. It does not need equipment. It's cheap. It only requires drill bits and wax. This is the type of inoculation result in slow colonization. And then you have sawdust spawn. So this maximizes efficiency. Spawn colonize about 30% faster and plugs than plugs, but requires some extra tool. So after you drill a hole, you place your sawdust spawn or your wooden plug spawn into it, and you want to seal that up with plastic, wax, paraffin, or anything similar to that to prevent drying it out. So when to inoculate? They are contradicting and inconclusive resulting about how soon after cutting the live tree the log should be drilled and inoculated. The answer may depend on the time of the year the log is cut. A tree defense are more active in the summer, and the weather, humidity, and temperature. Some suggest waiting for 4 to 8 weeks to allow the tree natural fungus fighting defense to die off, while others suggest inoculating as soon as possible after cutting the tree to prevent the logs from overdrying or competing fungi from contaminating the log. A compromise approach will be 2 to 4 weeks after cutting. Next, we'll talk about coffee ground. Coffee is also a good substrate. Coffee is the world's second most traded good, only after oil. Coffee is the world's second largest beverage, only next to water. Only about 30% of the coffee bean mass can be extracted into a coffee drink. A large portion of it end up as spent coffee ground, which has been mainly disposed of. So 9 million tons of coffee are brewed around the world every year. This results in an estimate of about 18 million tons of wet spent coffee ground. Some pros and cons with using coffees. You do not need to be coffee doesn't need to be pasteurized as it comes from a brew house. It's already brewed. It's simple to get started. It's easy to source a substrate. It's free. You can visit any local coffee shop. Some cons associated with using coffee as a substrate is easily contaminated. If you don't use it within 24 hours, other mold can develop. It's high in acidity. It's compact, so it's not aerated, so you need to mix it with other substrate like wood chips or straw. This is a contaminated coffee ground. So coffee grounds recipes involve use coffee ground within 24 hours of brewing. Otherwise, there'd be a greater risk of contamination. Add pasteurized straw or hydrated sawdust, pellets, wood chips to the ground coffee. So you want to use roughly about 20% of the coffee weight. It should be pasteurized straw, hydrated sawdust, or pellets or something like that. Oyster mushroom spawn. So you want to use about 10% of the coffee weight in mushroom spawn. You mix this all together and place this in a growing bag. Next, I'm going to talk about coco coir. So coco coir is a material made of ground up coconut shell and husk. Initially, manufacturers consider it to be a leftover byproducts after removing the coconut fiber from the space between the outer husk. You can grow mushroom on plain coco coir, but adding vermiculite with gypsum or other coffee ground increase the yield. Vermiculite is a yellow to brown mineral that is used to retain moisture. Some growers also add powdered gypsum to this recipe to create a substrate they call CVG, coir, vermiculite, and gypsum. The gypsum acts as a pH stabilizer and enhances the yield by supplying extra mineral and trace element to the mycelium. So some pros and cons with using coco coirs and vermiculite is, well, coco coirs and vermiculite is easy to source substrate. You can get this at any a garden or home store. It's excellent for aeration. It's highly moisturizing ability. It's naturally good at being disease resistant. Some cons are it contains high level of salt. So depending on how the course was treated, it contain the product quality varies between producers and has possible chemical residue. So most recipes call for 1 part coco coir and 1 part vermiculite. For a standard brick of dry coco coir of about 1.5 pound, add 8 cups of dry vermiculite along with 16 cups of boiling water. So this will pasteurize the coco coirs. So you soak the material in a 5-gallon bucket for about an hour. Then mix everything up and put the lid back on and allow it to cool for 4 hours before inoculating. So beware that coco coirs will expand by 5 to 7 times in volume when you add water. So you might end up with a lot of more substrate than you initially look. Next, we're going to talk about manure and compost. Most people think that mushroom grow on manure, which is indeed true. Although most gourmet mushrooms prefer hardwood or sawdust or straw, there are some common species that grow best on manure. 2 types of material are generally used for mushroom compost. The most used and least expensive being wheat, straw, bed, horse manure. Synthetic compost is usually made from hay and wheat straw, although the term often refers to any mushroom compost where the prime ingredient is not horse manure. Agaricus species such as the common button mushroom and the portobello mushroom, as well as many psilocybin species are a great example of manure or compost loving. We will go over manure and compost substrate in future lecture because of the complexity. So one of the last substrate I'm going to talk about is cardbox, simply because it's really easy to get. I mean, it's everywhere, right? We are in a shipping world right now. So not every species mushroom will grow on cardbox, but for those that will, we recommend giving it a try. Cardbox is free, and there's plenty of material that everyone can have access to. Growing mushroom indoor on cardbox is more environmental friendly compared to other substrate material that you use, because cardbox are literally waste. You can also use cardbox to grow and produce spawn as well. So some pros and cons with using cardbox are: cardbox is super easy to source. It's either free or cheap. It's lightweight. There's less contamination because it's poor nutrient. Some cons are of safety concern, especially if it's treated. The cardbox treated. That's often associated with low yield, inconsistent yield, and longer time for mushroom to fruit because of the lack of nutrient in cardbox. So is a cardbox safe to grow mushroom on? Cardbox are generally safe to grow mushroom on. Brown cardbox is made of recycled material, either existing paper product or waste product from the lumber industry like sawdust. Cardbox is unbleached and usually not treated with chemical, so it's considered one of the least processed paper product available. Cardbox container that comes in contact with food or required to use food safe dye, often made from soy or other natural material. Still, you should avoid cardbox that contain glossy or color ink. Black ink is generally okay. Color ink, which could contain heavy metal in their dyes, should be avoided. Also avoided cardbox that is treated with wax, fungicide, or other material that makes them water or grease resistant. To be safe, we recommend only using plain large cardbox that are used as shipping containers and have minimal ink on them. So you can use a lot of methods to basically treat the cardbox, but the recipe follow as is. First, you cut or tear the cardbox into smaller pieces, so anywhere from 1 to 4 inches, 3 to 10 centimeters is a good size. Next, you pasteurize the cardbox, so you place the shredded cardbox in a 5-gallon bucket, then pour hot boiling water over it, put a lid on it, and let it sit until it cools to room temperature. Then fill your grow bags and squeeze the excess water out of your cardbox, and then layer in your bags with mushroom spawn. Here, see people demonstrating it. Instead of mushroom spawn, they put the butt of mushroom, basically the end of mushroom. You can use other method to pasteurize the cardbox, such as lime and hydrogen peroxide and some of the things that we went over. You can make mushroom spawn also. Here a grower made spawn in a bag, another grower made spawn in a bucket. But basically the cardbox is cut up, soaked in hot water, draining, and then compressed. And you throw in a butt of oyster to seed it, basically. I'm using the term butt a lot, but what is a mushroom butt? Is it this? No. When we talk about mushroom butt, it's generally the bottom of the stalk that you're not going to eat. Make sure you remove any soil or anything that's not part of the mushroom, and place this between the cardbox and it will colonize the cardbox. Growing morel. So morel is one of the most prized of all edible mushroom. Its only moderate success has been achieved in its cultivation. In 1982, Ron Over, a student at San Francisco State University, successfully grew morel and report that sclerotia were important in the morel life cycle. Owen convinced Neogen of East Lansing, Michigan to pursue the endeavor, and they took out a patent on the cultivation of morel. However, others couldn't successfully duplicate its production, leading to question on the validity of the patent. Was their secret withheld? Generally. So tragically, Owen was murdered in a park in San Francisco a few weeks earlier and did not live to see the patent granted. Neogen set up a pilot plant and then sold the right to a patent of Princeton Mushroom of Florida and Illinois, who built a 10,000 square foot plant in Auburn, Alabama. The company succeeded to grow morel, but was not successful from a business outlook. After a few years of difficulty, it closed. There was a later attempt at the Michigan State University starting in 2005, but it lasted just about 3 years. The mushroom they were growing is a common morel found in landscape in California. So in California, you have backyard, you have wood chip like this. It's really common to find morel popping out, near the sidewalk, basically in wood chips. It's very common after rain or after in the spring, even summer. So there are several ways to grow morel. One is to manipulate the outdoor substrate and hope for the best. It sort of work. Yield will vary between 0 and some mushroom. A business plan on the model would be difficult to justify. One can relatively find morel kits, sawdust spawn instruction online. You might mix your spawn with wood chips, leaves, and compost, along with peat moss, wood ash, gypsum, lime, and perhaps something else in your outdoor garden bed. Keep the bed moist and hope for the best, basically. This is, under a shade cloth. If you do this, sometimes you could get yield. The other way to cultivate morel is through the production of sclerotia. A stage of a morel life cycle is not present in other cultivated mushroom. It's called a sclerotium. The sclerotium of the morel is a relatively large structure. It's 1 millimeter to 5 centimeter in diameter. It's composed of large cell with very thick wall that allow the fungus to survive adverse natural conditions such as winter. So in the springtime, the sclerotium has two options for germination. So it can form a new mycelium or to form a fruiting body. So unfortunately for the potential grower, it's very easy to get the sclerotia to form a new mycelium, but very difficult to force it to form a fruiting body. Very specific condition of nutrition, humidity, carbon dioxide level, and temperature must be met for primordia to form. The primordium is very prone to abort at this stage. So if not given the proper set of conditions, which may be very different than those that allow the initiation, it's best a very tricky business. In the wild, some possible reasons for difficulty in fruiting the morel are made very clear by examination of the time frame involved in fruiting of fire-induced western morel. So a massive fruiting of morel occurs after a forest fire. Many spores are released and eventually germinate to form mycelia and then form sclerotia before the next snow cover. They do not fruit again, existing in the soil in the form of sclerotia or cycling between sclerotia and mycelial stage until the next forest fire, on the average of about 80 to 100 years later. So given this time frame and our lack of knowledge concerning the natural role of morel in this ecosystem, it is not surprisingly that artificial cultivation of morel, even outdoor, is still difficult. Morel sclerotia do not normally form until the nutrient of the substrate have almost run out. So one trick to forming large sclerotia is to inoculate morel mycelium on a nutrient-poor substrate, such as soil, and allow it to use its limited nutrient reserve to reach a nearby nutrient-rich substrate. So the nutrients are then translocated back into the old mycelial mass where the sclerotia are formed as they begin to store the nutrient as lipid. These sclerotia can often be quite large and have a very much the same consistency as slippery feel as walnuts. So when the sclerotia are mature, the nutrient source is removed and the water percolate between the sclerotia in the soil, perhaps stipulating spring rain. After 10 to 12 days, small primordia appear, and if the conditions are correct, the morel mature in 12 to 15 days. On the surface, it seems very simple process, but as with all mushroom, there are many points at which a grower can make mistake and lose the entire crop. Basically, this is the life cycle of morel. It forms spores, spores release, it germinate, it forms mycelia. Mycelia can form canidia, and it could go back to this stage. It could also form sclerotium. Sclerotium could go back to form mycelia, or the sclerotium can germinate. So this is, a long cycle. So the steps of morels production is, the first step is spawn production. So to produce spawn, first you grow in 1 part potting soil to 5 part grains. This needs to be sterilized and inoculate the jar and place the jar in a cool, roughly 68 to 71 Fahrenheit dark place for approximately 4 to 6 weeks. Good growth will be indicated by whitish strand of mycelium growing throughout the medium. At about 5 weeks, small aggregate of white or rusted colored mycelia sclerotia will form. After sclerotia are visible within the jars, prepare some clean trays to receive the mix for fruiting. See, white mycelia, this is the sclerotia that are forming. So next, you want to make the fruiting substrate. To make a fruiting substrate, mix of 20% sand, 30% potting soil, 50% organic material composed of basically 80% small hardwood chips, 10% rice hull, 5% sorghum, 5% sphagnum, and a small amount of lime to bring the pH to 7.1 to 7.3. So you fill an autoclavable aluminum or aluminum pan with this. So this is called a top pan. You fill the substrate up. The substrate, and then on the bottom pan, you want to create a nutrient-rich substrate. So you want to soak, drain ryegrass seed to a depth of 1 to 2 inches down here, and then you place this substrate over this, and you autoclave this for at least 1 hour. Next is spawn runs. So in a clean room, basically under laminar flow hood, you want to put your spawn onto the top tray. So you want to add about 1.5 cup of spawn into this tray, mix well, and then close the tray with a plastic bag, and place this in the dark for 4 to 6 weeks at 65-70 Fahrenheit. During this process, the spawn runs. The relative humidity should be kept around 90 to 100%. CO2 about 6,000 to 9,000, and no fresh air exchange. After 4 to 6 weeks, the surface of the substrate should be covered with sclerotia. The hard sclerotia lumps are secret to Growing Morel. These are seed of your mushroom. So keep unused spawn refrigerated at 38 to 40 Fahrenheit. Spawn is viable for a year under optimal condition. Next is pinning. So after spawn run, you want to remove the rye seed tray from the bag. So remove the bottom tray, and you want to reclose and place the bag substrate tray into refrigeration for 2 weeks at 40 Fahrenheit. So after 2 weeks, you want to remove the bags from the refrigeration. So remove the substrate tray from the bag and place in fruiting chamber or room. So slowly saturate the substrate with sterile water that's 65 to 70 Fahrenheit. So you want to basically saturate it with water at a 1.5 to 2.5 fluid ounce per hour per square foot of substrate surface. You want to do this for about 12 to 16 hours. Then you want to allow the substrate to completely drain for about 24 hours. Next, you want to add a casing layer. So this is optional. Layer of casing with soil eventually to a depth of half an inch. This allow about 7-10 days for the material to run through the casing layer. Air temperature should be kept around 65 to 70 Fahrenheit. Filter fresh air exchange at about 1 to 2 per hour. And keep this in dark. Primordia will form 3 to 7 days. Substrate moisture should be kept around 60%. Relative humidity 95 to 100. Air temperature around 70 to 73. Filter fresh air exchange every 6 to 8 hours. You want a light cycle about 12 hours on, 12 hours off, grow lights, and you want to keep CO2 less than 900 parts per million. The last step is fruiting. So fruiting, you want a fruiting moisture around 50%, relative humidity around 85 to 90, air temperature around 73 to 75, filter fresh air exchange 6 to 8 hours, and light cycle 12 hours on, 12 hours off. Keep CO2 less than 900 parts per million. And best of all, you will need luck. That is it. Thank you guys, and have a great day.